Okay, so here we're going to look at what they call a confidence interval for a mean. So, what are we talking about? So, just like before when we talked about that polling data, and you had that plus or minus value, the margin of error, so you got that interval. Um, we're going to take the margin of error, we're going to subtract it from the mean, add it to the mean, in order to know where the true average lies. So it has to lie between two numbers. Again, statistics is not an exact science for this, so we have to have some wiggle room. Um, you know, kind of a bad example, I guess, but one that's recently in the news. You may have heard. Hopefully, information has updated and changed this, but a couple days ago, the projections for deaths in the United States related to the COVID-19 coronavirus range from 100,000 to up to 240,000. Okay, that's a very wide interval, but that is, again, a confidence interval. They didn't tell us how confident they were, percent-wise, but that's their data that they're telling us. The low end is going to be 100,000. High end is going to be up to 240,000. Whether that remains true or not, depends on how effective all of our, social distancing and things like that are. So when we have a confidence interval, you really want to be pretty confident, right? And it is exactly what it's saying, like, how confident are you? And if you're like, oh, I'm 100% confident, well, that's great. That means, you can't be wrong. As you see in table F, there is no 100% confident, right? So we go from 80% confident to 99% confident. This is pretty dang sure, okay? Based on a statistic level. Usually what you're going to see is right around here, somewhere between 90 and 95%. If you're using data that's only 80% confident, it's not the best. It's not that it's worthless, but tend to be over here way more than these two, okay? So you do want to be as confident as possible in your results. And I'm saying this as if you're going to go out and do research. So if you ever go out and do research, again, this is where these things come into play. Okay. So this looks gross. I know it looks a little intimidating, but we actually know everything in there already. Okay. So what this is saying is that we have a sample average, a sample mean. From that, we are going to subtract this value. And my daughter just came home, so 1 second. Good? Okay. All right, you're fine. She went to Sonic. She did not socially distance. Okay. And when we got this earlier, this was the formula for what we did right here, right? There it is. So we're doing the exact same thing we did in those polling examples. We have the margin of error, is right here. We subtract it from the mean to get the low end, and then we add it to the mean to get the high end. These are the exact same thing. One's a plus, one's a minus. And so this right here, we're not going to replace this with. This is saying this is the symbol for the population mean. Okay. So what we're going to do is we're going to take the sample mean given. We're going to subtract the margin of error. Take the sample mean. I'm going to add the margin of error. And all this part is that the population mean is somewhere in between those two numbers. So that's an inference from sample data that we're going to infer on the population. Okay. All right, so let's do it. Here it says a random sample of 50 cars in the drive-through reveals an average bill of $18.21 per car. Population standard deviation is $5.92. Estimate the mean bill, so the average bill, for all cars from the drive-through with 95% confidence. So you're going to run your data and you're going to tell your general manager that you're 95% confident of your result. We're going to pick out the numbers to use and plop those bad boys in. Okay. So here it's like asking for the sample average. Okay, it's not the first number we see, it's the sample average that they give us. So here it says that they took a sample and that average was $18.21. Gonna pause for that here real quick. Gonna go to the population standard deviation. So it tells us that it's $5.92. N is the number of, in this case, cars, or people in cars, I guess. So there's 50. And so now we need to know what number to replace this z-score or this z-alpha number with, okay? And again, this is based on being 95% confident. So we look at our table F. And 95 is right up here. And we could look all the way down, all the way down. So 1.96 would be that value. Okay. So this is where, if you're just putting the values in to this formula, that's great. But if we were in class, this is where I would start threatening you with physical violence if you do not do order of operations correctly. Okay. We have our average, which is 1821. Going to subtract, and then we're going to get this number separately, or like as it is. This is the margin of error. That's what we subtract, and that's what we add, okay? So when you are doing math, you do not subtract before you multiply. If you try to do that, that'll make me really sad. Okay. Usually I get lazy and I just write, yeah. Because whatever number this is, ugh, I wrote it terribly, sorry. Whatever number this is the same number we're going to subtract from 1821. We're going to add to 1821, okay? So we get this number first, this value, this margin of error. Oops. All right, I'm going to try to hit the right buttons. 5.92 divided by square root of 50 times 1.96. Okay, it's something that's, you know, obviously not a nice ending number. So the rule of thumb for rounding for your answer is your final answer should have one more digit than you were given. Okay, so we're talking about the average. Here our average, we had 2 spaces. So we want to go 3 spaces. So we're going to use 1.641. That 9 is big enough to change that. All right, so the margin of error equals that. Okay. So we're going to subtract that from our sample average of 1821, and then we're going to add it to our sample average. So our low end is going to be and okay. So here, this is how I'm used to writing it, is that the population average is between $16.57 up to $19.85. Okay. Your Newton homework, they might have you enter it as an actual interval. So they might have you enter it like this. Like that. Either way, same thing. Low, high. Low value, high value. So here, when we talk about what does this mean in words, just means kind of what I said, that the average for the drive-through bill for this restaurant should be between $16.60 to $19.85. That's what you would report to your general manager and not sound like an idiot, right? That is always important. What I usually ask my class is why would anybody want to know this information? Why would that make a difference? You know, we're talking about a lot of medical stuff recently, so obviously that makes a big difference, but you know, why would a manager or a store want to know their average drive-through cost? And then usually what happens is people have very trusting answers, but there's always somebody in class that says, in case somebody's stealing. And that's usually what happens, right? If your average bill all of a sudden goes down to $5 for a stretch when a certain person is working, you can probably, you know, have an idea that maybe they're not being a very good employee. So information gathering is important. Okay. So do these two and then see what we notice about those intervals, okay? So here it says a random sample of 49 shoppers showed that they spend an average of $23.45 at this bookstore. They give us a standard deviation and find the confidence interval for the true mean at, and they give us these different levels. Okay. So here, the average is 23.45. They give us the standard deviation of $2.80. They tell us 49 people are shoppers, or there's 49 shoppers. And so our Z value that we get is based on this first one, this 90%. So we look at 90%. There it is up there. And we go all the way down, and we get 1.645. Okay. So the formula is that we're going to take this, we're going to subtract the margin of error, and we're going to add the margin of error. How to get the margin of error? We're going to take this Z number, and we're going to multiply it by this. Okay. So we put that in. Our Z is 1.645. Standard deviation is 280. And our N is 49. Okay. And then we times that by 1.645. And we get 0.658. So that's the margin of error. We're going to subtract from the mean. And then we're going to add it to the mean over here. Okay. So this is kind of where I would like you to focus on, is that you're going to get the margin of error first. And that's the value that you subtract and add. So all of this looks really gross. I know. But it's only one little multiplication thing that you have to do. And then you subtract it. And then you add it. And that's all you have. Okay. So in this case, if we are 90% confident, then our range or interval be 22.79, 24 point, as we're dealing with money, I just rounded. So what about 99%? So the more confident we are, how does that affect our interval? Well, let's find out. Everything else here is the same. The only thing that's going to change is that Z number. So if we're 99% confident, then we're going to use 2.576, a bigger number. Okay, now I'm running out of room. So again, we're going to find the margin of error. Yeah. And subtract it from the average and add it to the average. Okay. Margin of error again is that. So we're going to replace Z now with 2.576. There's holes in my table. I can go through. All right, 2.8 divided by square root of 49, still 0.4. Multiply it by that Z value, at 1.03. Okay. Think about what happened, right? We're 90% confident our margin of error is about 66 cents, plus or minus. When we're 99% confident, our margin of error is $1.03. So when we subtract that, and we add it, good, 22, 42. Okay. So not a huge difference, right? If you look at the low numbers, this is at $22.79. This is $22.42. Here's about $24.11 for the high end. Here's $24.48. But what you notice is that margin of error increases as your confidence level increases. More confident you are, you have to be more confident that your true mean is in between these numbers. So it widens the interval. Okay. So the more confident you are, bigger your interval is. To make sure that you are capturing where that true average is. So maybe that's why they are estimating such a large interval for, possible coronavirus deaths. Hopefully won't be any more than they say. And hopefully we'll all come out of this not so fat like I'm getting.